Здравейте, добър ден! Това е нашият вебинар AI in Manufacturing, който ще проведе на английски. So, for everybody who is joining today's webinar, I'm Благовеста Погьова. I'm co-founder and CEO at Fabrico, and I will be talking on the topic today, AI in manufacturing, together with our special guest, Dr. Георги Налбантов. Georgi is one of the leading data scientists in Europe in the past 20 years. He has experience in implementing advanced data analytics solutions in manufacturing, pharma, and healthcare sector. His areas of expertise include vast areas of AI, including predictive analytics, decision support systems, consumer analytics models, NLP, image recognition, autonomous vehicles, which is quite interesting, and we'll see a case study today about this and many others. And he has 100+ publications on topics of data science and AI. Georgi, welcome today. Hello.
Welcome everybody. I hope you can see me, because I don't see my face, but I see the presentation. Let's see. Yes, I think you can see me very well. Thanks, Blaga, for the introduction. I'm honored to be here and to be able to share our expertise in AI in manufacturing, especially the recent trends about how AI could be used in manufacturing and where it is actually used. This is a busy slide, but this gives us an overview about what are the main applications of AI in the whole line of manufacturing, starting from raw materials through production and the end product. So regarding raw materials, there are many solutions, starting from smart inventory management and procurement. Basically, here the idea is to have AI or machine learning or statistics models that are managing the cash flow in such a way that there are just enough spare materials in the inventory, and not too much and not too little. And basically, when we talk about large scale, this has to be done in some statistical mathematical way. Now moving to production, there are extremely many ways where AI can be applied, but the three most important topics are the operations, equipment, and quality. For the operations, it's about lean technologies and approaches such as process mining. So how to produce on several lines simultaneously many products in the most optimal way, so that it is so that the production is done in a least amount of time. So there's also lots of mathematics and AI methodology behind this. Basically here the KPIs on time in full and others that have to be taken care of. Equipment, predictive maintenance, mostly, and spare part inventory. And for the quality of the product, it's of course computer vision that is checking if everything is okay. For the end of product, most importantly, it's the demand forecasts. And of course, stock of inventory. And above, that is something that is all-encompassing, is workforce analytics, CRM marketing. So there are lots of chatbots, smart communications, BI on demand, knowledge-based on demand for troubleshooting, etc. That is gaining now lots of ground, especially the voice bots and chatbots. Yeah, so we continue with the maintenance case studies, and it's most interesting to speak from first hand. This is a project that we have been running for almost 8 years, so long before the LLMs became synonymous with AI. So this is with the traditional machine learning, and this is precisely a case study on how machine breakages can be predicted ahead of time in order first to optimize workforce, then to optimize spare parts, but also to be able to fulfill service level agreements, such as, for example, 99% availability. So it's very important to be able to manage this process and have, for example, a KPI such as, let's have 0.1% chance to break our SLA contract, which is for 99% availability. So there are lots of predictive maintenance models, short-term, mid-term, long-term, that are related to making models about sensor data, about vibrations, about belts, and so on. About generators, X-ray generators in some cases, that need to be made in order to run the production smoothly. Yeah, so maybe let's go to the next case study. So this is a more modern case study about virtual AI assistant. It's basically BI on demand, and this is a hot topic in the whole manufacturing industry. Basically, this allows to build the chatbots that communicate directly with the whole knowledge base, with the data on the workforce, with the data on machine functioning, with the troubleshooting guides, case studies, etc. So that, for example, technicians can tap into the knowledge of how to repair a certain machine without spending too much time. And maybe they could require to see what was the performance of this machine for the last 2 hours in detail, and instead of going to a BA specialist to do this, the AI chatbot is taking over. So this is a interesting new trend, business intelligence on demand. Okay. This is about production planning. So that's a more traditional task, but recently it has been done with a combination, using combination of machine learning, mathematics, and AI tools. So this gives you the idea how to produce several products on a number of lines simultaneously. And basically, if you have the planning, which you normally do for, let's say, it takes 3-4 hours to do the planning for 2-3 weeks ahead. And then during already the second day, you realize that the plan has to be adjusted. And now the question is, if you adjust the plan of one line, you have actually to adjust the plan of other lines because the resources are fixed, etc. So this type of software and solutions gives you the possibility to readjust the planning in real time, so as not to pretend that when the plan breaks, let's just continue as usual. We know then that there will be lots of delays, in some cases weeks, like 6 to 8 weeks of delays. And the AI part here is connected to the decision on which replanning to choose, because the mathematics can give a lot of replanning options, but then the AI can choose which one is most appropriate. So that's a new trend as well. Okay, let's go to the next one. That's a pretty traditional case with computer vision, but this is one of the showcases of AI modeling in manufacturing. Basically, on a production line, there are a lot of end products that have to be checked visually for control of their quality. And traditionally, this has been done by lots of people, but recently, maybe this is now almost everywhere, via cameras, machine learning models are trained so that to be able to catch any defects. One thing that is common for all these cases is that AI models have to be trained using lots of data. Sometimes for predictive maintenance, it is years of data. In some of our cases, it's 10 years of data. So you do need service protocols, machine data, production data, in order to be able to build models, so that it could have been very easy if some AI model, even for computer vision, can be just deployed in a factory. But the truth is that if it is not trained on the images and on the data of the factory, it just cannot function. So you always have to keep in mind that there is such a period of time where the model must be trained on historical data in order to function. Yeah. So another case with computer vision and interaction with a workforce and technician is where computer vision can be used basically to monitor movement of personnel, of workers, and then check if something goes out of plan, either due to delays or due to some wrong movements. And basically, this is used first for safety and then for increased production. Lots of resources must be monitored simultaneously, like heavy lorries, cranes, workers, so that actually one can measure if the safety instructions are abided by all the time. Interestingly, computer vision can also be applied in cases where one cannot just immediately find the connection between AI and the problem, which used to be standard in the industry. So there is a problem in the industry, but the solution, the industry people, they couldn't find out themselves that these problems are solvable using AI and machine learning approaches. And when this becomes evident, a lot of breakthroughs can be done. For example, this is a case with sensor technologies in a coal mine. It's in Germany. And here the idea was the following: there is an excavator machine that must excavate lots of coal, and normally it is being directed how to excavate by a person, and unfortunately there are a lot of casualties every year because this is a very high risk job. And the idea here was to build a solution that automatically tells the machine where to excavate. So this is a non-standard approach, so you can't find this solution somewhere on the market over the counter. Basically, lots of data must be collected, lots of types of different cameras, infrared, normal, etc., and then integrate this into the production. So basically, you have the solution, you have the integration, and you have the interface that must tell you what is going on. And about the interface, Blaga will tell you a lot, which is a very important part.
Thank you, Joro. Thank you, Georgi. It's first of all, I have some questions for you. You don't hear me. Will you hear me now? No. Okay, I'll try again.
Not yet. Oh, we do.
And do you hear me now? Is it better? Do you hear me now? Okay. Okay. Then Joro, I have some questions
Yeah,
to you.
thank you.
Thanks a lot. You mentioned some things that I'm eager to ask before we continue forward. So one of the things you mentioned that some of the case studies you use traditional machine learning and some of the others use the modern LLM techniques. What is actually the difference between those, and how do you choose which one to use? And just something that many people think at the moment with the advance of all the open AI models and the other similar models. Everybody, not everybody, but many people think that the new LLMs can do everything. Is it true? And what's your opinion on this?
The LLMs, they cannot do everything, but one thing that is that is good about them is that people don't ask anymore what is AI. So basically, before you have to go to a client, to manufacturer, and start explaining like from scratch what machine learning can do. And it took like maybe days before somebody gets acquainted with this domain and understands how the domain can help. Now it's the opposite. Now we know the LLMs, and we say, okay, LLMs can do everything. Just do it for me. So it's the other it's the other end. LLMs can do a lot when it's about creativity, about ideas. But if you ask, if you expect the LLM to solve, for example, a planning problem, good luck. It's not possible to do that. So we have to know what are the limits of language models. And one common fallacy is that, for example, one can say, I would like LLM to make me a predictive model for some breakages. So the LM model is already a model. It doesn't build new models from this logic, at least not yet. Maybe in the next 10 years, this could happen. But just we have to set the right expectations. If the LLM model does not have access to historical data of a company, and historical data is needed to make a model, then the LLMs cannot do anything. And reversely, if there is a lot of unstructured data that must go into modeling, then LLMs are very good to be used to make this unstructured data into structure. And this is now an input for a real machine learning model that is able to predict something.
Okay, and which are the cases where the LLMs you mentioned, when you have structured data, you prefer the traditional models? What about in computer vision? Is it still in the traditional modeling, or you can still implement some LLMs there, like the prompting or some part of the process, or it's still clear computer vision?
Yeah, computer vision is one of the cases where LMs are not directly applicable, just because you need really mathematical models for computer vision that learn from how a product should look and then how it doesn't look, and then make a specific model for defects. So LLMs, what they do is that if you, let's say, give them a picture and say, find me something in the picture, they will go on the internet, download some open source computer vision program, feed the data into that program, and give you a result, which is something that one can do on his own, because this is like free models applied to your data, pre-trained models. But if the defects are specific to your company, and you haven't uploaded any images on the internet about these defects, then LLMs cannot help.
Okay, back to the computer vision. What you mentioned, like, so how often in real cases you need to have custom computer vision models, and how often you can use something that's ready out of the box? Is it that in manufacturing most of the cases are custom? This comes from Mike asking for, like, looking at a camera that says it's so expensive because it comes with ready-made models to recognize the movement of people in the factory.
Yeah.
Is it actually applicable in real case studies, or we always need AI
In some cases, yeah, that's a good question. So if it's a rudimentary case, let's say it's a case that is repeatable in many areas, like movement of people, as you say, everywhere. This question could arise in all factories. So, are there people moving or not in an image or in a video? Uh, if you solve this question for, let's say, 2-3 clients, then you can very easily transfer this knowledge and this model to a fourth one, because the task is the same. So if the task is the same, which is follow people moving, then you can use one computer vision model as readily applicable to other cases. And of course, if there is something specific, like this is my product, is it defect or not, then it's different. Then from factory to factory, the task is different, and then it cannot be replicated easily. Also, think about computer vision when you have to recognize plates. So if you recognize plates of one car, you can recognize plates of another car. But if yeah, so these are tasks that can be copy pasted. If it is something more concrete, then of course you have to think of different solutions. In the case of the skull mining, a new camera had to be invented as an IoT device in order to be able to work in dust conditions, for example. So of course it depends even on with computer vision what could be the application.
Ideal cases are rarely found. And what about the same question in predictive maintenance? Can you have a ready-made solution for predictive maintenance and say, I would apply this, I just buy already software for predictive maintenance and I use it for my machines?
It's rarely the case. It could happen, for example, if you have vibration case studies with, let's say, one company that is producing machine parts, and these machine parts are standardized across factories. There are such companies, and then they have a specialized software specifically for these parts to monitor them and to predict when they break. But these are the same parts. So if you have one and the same part in several factories, you have just one and the same task. As long as you have something specific that that is pertaining only to your factory and has not been done in other factories, then it's impossible to have a predictive maintenance model readily available from somewhere else. Just imagine, how is it possible that somebody else has built a predictive maintenance model for you when nobody else needs it? It's very unlikely that somebody will take this effort. Plus, data, sometimes for a lot of years, sensor data, workforce data, service protocols, etc., has to be put into a model, and these are really custom models for your machines and for your systems that have to be built. So unfortunately, we are not yet at the stage where we can copy paste such models very easily between manufacturing companies.
And you mentioned that in the first case study, you had 10 years of data for the predictive models. What is at least the minimum amount of data? Is it like calculated by volume or length in terms of periods that
Yeah.
we need before we start such an exercise?
Depends on the frequency of breakages. Only that. So if some machines break once in 2 years, and let's say we had 40 of them, then you need 10 years of data just to have enough failures to make a model. If something breaks every 2 weeks or every 2 months, and you have lots of cases, then you don't need 10 years of data. It depends on how durable the asset is and the frequency of failure. That's all. In order to be the model, to build a model, you need to have a history of failures and history of normal functioning of machines, and then you can make models that distinguish between normal state and a failure state, and then alert the technicians about the health status of the system. But of course, the system uh, has very specific data from which you learn.
Okay, and in terms of project length, like what is the standard time that a team would need to create a predictive AI model for, let's say, a project that involves several machines in a factory with good data? Is it, just to give us an idea of what to expect, is it a 1 month or 6 months or 12 months or years? And
Yeah.
what is the maintenance in such a project? What do we need to devote as resources if we are a
Yeah.
manufacturing company?
So the rule of thumb is that POC can be done between 3 and 6 months, and normally the first 3 months are centering on collecting data and cleaning data, and basically putting the knowledge of the technicians into a model, into the inputs of a model. And then the data scientists, they know how to use inputs, characteristics, and description of processes, uh, together with failure and non-failure cases, normal cases, how to build a model. Mm, and once a model is built, let's say between 3 and 6 months it has taken, it's built on a number of cases, as I said, which consists of normal functioning of system and failure modes. Um, and this model can function very well. However, if, let's say, during the next 3 to 6 months or 1 year, a lot of new failures have been observed, then it is beneficial to update the model. So this is about maintenance of the model itself. The model learns from new failures, and if the model is retrained, it becomes better with time. So our advice always is to recalibrate the model with new data at least once every 3 months.
Okay, then this opens the door to my next topic, and I would like here to take a couple of minutes just to share a bit about Fabrico, because this is something we've already discussed with you. That when you go somewhere starting a new project, like having good structured data makes it easier to go to to delivery. So this AI maturity is not only to have a strategy to implement AI, but first of all, the foundation and the tools you have and how easily you can access the data in these tools is something important. And that's why Industry 4.0 and digitalization is actually a prerequisite, and it's a must to have before starting AI journey. Because what we've seen working together and going together to clients, as you from Vector Labs and I from Fabrico, it's often the case that we have this data in Excel we can give it to you, and please help us create an AI model. And this makes the tasks very difficult. So I'll share a bit about Fabrico and how we work with data there, and I'll get back with some questions again to you.
Yeah. As you said, as you also mentioned, this is very important to get the data correctly and to be visualized correctly. Because if you lose 3 months on gathering data, lots of like a modeling cases become just not interesting. But as long as you have this data, you have much more opportunities.
Yeah, it's true. This is what we do in Fabrico, actually. We actually, one of the reasons to when we started working on Fabrico and developing it as a SaaS platform was a case where a client wanted predictive maintenance, but in fact the data wasn't available and it was scattered between Excel and paper data. And to the question, can you scan our protocols from the maintenance people so we can get the reports? You realize that many people just don't evaluate how important it is to have digital solutions, and that they give the step towards AI. So that's what we do in Fabrico. We have, first of all, a cloud solution, which makes it easy for any other solution to connect to it. It is web-based, it has APIs, so any AI model and any AI provider like you can plug in and use this data and easily create models based on the historical data. On top of this, we have integrated solution for MES, manufacturing execution system, OEE, overall equipment effectiveness, enterprise asset management, or CMMS, which is maintenance management and asset management solution. And on top of it, having any AIs, any AI add-ons on AI solutions that can be plugged into this system is already quite easy and able to implement quickly for not only for our solutions, not only for custom solutions of the client, but also any other ready solutions that is there on the market. And I see a huge trend in manufacturing companies shifting towards cloud solutions as well, because let's say that 10 years ago, it was something almost a banned topic. Like, we are just on premise, we have our servers, we only get solutions on premise. But with the developments recently, the cost of having cloud solution and the risks are much lower than the risks of maintaining your own servers, and the risk of losing data because you're the only one responsible for this. So this is something we have learned together, and this is something we work on in creating solutions that implement richer historical data so that it can be used in predictive maintenance, and it can be used in any kind of models related to the production output as well. And I see from what you're talking that it's obviously a good way to think and go forward. Something else that we are working on at the moment and scaling up is making Fabrico 100% visibility on inefficiencies. The idea is to be able to collect the true master data for the equipment, and in this way we connect to the machines. So we get the data through IoT sensors, we get the data from the POCs of the machines. But people in factories and on the shop floor, they usually know that the machines know a lot, but not everything. So based on our statistics, you can get like 70% of the data about the equipment from the equipment itself. but a huge portion of the information is held within people. So that's why we also focus on good interface, so we can have the people in the loop and can make sure that they are reporting true data and they have the willingness to participate in this process, so we don't lose the information. And whatever you get from the machines and people, there are still black zones and unclear data that the owners often miss. And you see that the output is not very good at certain periods, but you never know why. And that's why we have included this out-of-the-box solution in Fabrico. And we have been working together with you and your team, Georgi, on this as well, creating models that can recognize different trends around the production line, so they can give a insight or a suggestion what was the actual reason of the specific downtime that wasn't reported neither by the machine nor by the people. So we really target to achieve 100% visibility on inefficiencies, and there is no other solution on the market to do this. And this is actually in line with the lean philosophy that many factories apply already. But the initiation of this feature in Fabrico came from several clients who were trying to, first of all, abolish inefficiencies, and second of all, to focus on anomalies and stoppage reasons that could be prevented. And following the Kaizen philosophy, zooming in this problem, zooming in before the problems occur so they can be prevented. And having a camera that is synchronized with the timeline of the OE system, for example, is something that can give you a lot of information about the really critical moments, and not even counting the discipline that the workers on the line have, knowing that everything can be synchronized with the exact moments of inefficiencies and nothing can be hidden from the management. So it's something that for myself is an advance in terms of moving Fabrico towards AI solutions, and being a solution that gives good data for AI development of every manufacturing company. So Joro, what do you think about this? And
I agree. Having such BA tools and being able to have infrastructure that connects all the data from IoT devices camera is a prerequisite for any good AI model. Because if there is scattered data, not enough data, not clean data, and not on-time data, then neither this is useful for management, for workers, or for AI models. So traditionally, business intelligence solutions, and now I see Fabrico as a very, very advanced tool, is used by the managers in order to control and see how the production is going and what are the machines doing and the workforce, etc. And of course, now these data can very much be used also for AI modeling. And in the solutions like Fabrico, you can also see not only the real-time conditions in the factory, but also predictions on some systems, how they could function. So AI modeling are very well integrated into BI platforms and MES platforms like Fabrico. Basically, the AI model output have to live somewhere, and the best way to live is in such solutions.
Yeah, it's something interesting because I was focusing on how we get the data to create the models, but what you're saying is that where actually the employees or the people that are using it see the outcome of the model and implement it. And this was exactly the case you shared with the production planning, because once you have the good mathematical model on how to structure the planning, then you either need to create a solution that is able to visualize all the planning so that every worker is able to see it so they can follow it. But otherwise you need to plug in the same data into like SAP or another ERP system that is used, and this might have some limitations. Is it
Yeah,
something
yeah,
that
yeah.
you do, or
It is true. This case also, I was thinking about the predictive maintenance case. For example, if there is an alarm that a line will be broken within 2 days, you would like to see this somewhere, this alarm. And basically, the best way to see it is on the dashboard where you visualize the line. Just an alarm is sound, and then you go and check what is the alarm, and then you go and check deeply what are the conditions of the system. Because I noticed that sometimes especially the service technicians that are with a vast experience, if they go deeply into log files, into sensor data, they realize what is going on. But if they have lots of machines under control, they just don't go and waste their time for 1 hour checking if something really works with the IoT devices. They will check something if there is an alarm, but then somebody must give the alarm. And these are the AI models.
yeah, it's true. And does it mean that these predictive models are like saying it in this way positive? It sounds like it is supporting the maintenance teams, and maintenance teams should be welcoming such solutions. Do you see a trend where the predictive maintenance models are being accepted more and more, or it's the opposite? Because like several years ago, it was. I've heard such comments like, "I know what to do with the machine. I don't want a computer to tell me." But as you explain it, it's just a red flag. Go and check this machine earlier, and it doesn't hurt to have such reminder.
Yeah, that's a very good point. Everybody prefers business as usual, so everybody is resistant to change. So this change must come from the management, because in the end, the management benefits most if there is more efficiency in the production process. Um, Definitely, so these AI models, they come under the head of decision support tools. So everything is decision support. Visualization, alarms, predictions is decision support that leads to efficiencies. And I agree that the most skilled workers, they know how to fix a machine. That's not a problem. The problem becomes when you ask um, even the best service technician, let's say I have 40 assets under management. What is the probability that 3 of them will go out of order within the next week? That's not possible to answer by the best technician. But this is extremely important for the inventory of spare parts, because if you have to order a spare part that takes 3 weeks to be delivered, you would like to know 3 weeks in advance it will be broken. And this is like not human to be able to make such a prediction.
Okay. And around the end of our talk, I would like to ask you for like an advice coming from your experience on for both management in manufacturing and the operational employees on adoption of AI. So, what would be your advice for both?
Yeah, AI is definitely coming to increase efficiency, but my advice is please, if you please don't rush into AI, because sometimes it could be fake. So if somebody comes and tells you I have a text LM model that will solve all your computer vision problems, maybe it's not the case. So my advice will be AI can help a lot, but please ask professionals how exactly it can help.
And what about the workers? Should they be afraid of what's coming to them? Will this take their jobs?
Uh, the the workers are always afraid of that because AI will make them more productive, and they, of course, they internally think that this will make them work more. Some think that it will make them work less. So in both cases, they are afraid. But in order to stay competitive, you do need to be more efficient.
Okay, this is a good point to end the talk, and we're out of time. But thank you, Georgi, a lot for your time. And also, as we started with it, Georgi is the Chief Scientific Officer at Vector Labs, and they're working on AI solutions in manufacturing. So anyone who is interested for an intro can either get in touch with us in Fabrico or just visit the website of Vector Labs. Thank you, Joro. Thank you, Georgi.
Thanks everybody for listening and being here. Thanks, Blaga, for the invitation.
Thank you again.